Welcome back. We are up to, this has been a long chapter, right? Whether you're here, there, or wherever you are, it's a long chapter, so thanks for sticking with it. This is the last one, and if you can do the warm-up problem, you can do everything that we're trying to do here. So let's just jump right into it. If we want to solve the system of equations, you guys know me well enough. When I see 5, 20, and 15, I'm like, you know what? Let's divide this thing by 5, because by George, you are almost an Algebra 2 student. You're an Algebra 2 student, right? Okay, so we want to make problems easier any place we can. So this is negative x plus 4y equals 3. Man, that looks a lot nicer. Now, does it solve the entire problem for me? No. Okay, I'm gonna multiply it by 2. Right? Why am I doing that? Because I want to get this 2x and this negative x the same thing. So here we go. Negative 2x plus 8y equals 6. And now it's time to drop this other one right down here. So it will look good in yellow. I like yellow down here. Alright, 2x minus 3y equals 4. Just the way it is. Here we go. I got negative 2x, I got positive 2x. Add these bad boys together. That's elimination. That's what we're after. That's what we wanted. So now you got 5y equals 10. Y is 2. Alright, and then plug it back in here, and we'll get the other half. Alright, so we're going to get x equals y was 2. Let's make that 2, so let's call this 6. We're going to add that. I believe we got 5 when we do that. Right? We're going to add 6 over, so 2x equals 10. So x is 5. So 5, 2. That's what we're after. So if you can do that, then we're in good shape for half of it. Now the other half, do you remember how to factor this guy out? Now, some of my friends, we called these JV problems because this had a 1 in front of it. That made them a little bit easier, kind of like being on the JV team instead of the varsity team. All right, we want different signs. We want 18 that are 3 apart. What do we got? 6 and 3 for that. So we want positive 6 and negative 3. So x equals negative 6 and positive 3. Those are my two solutions. If you can concept these two things, we're going to put them together like a casserole and solve it out. Alright, so we're going to take a linear function and a quadratic, and we're going to put them both on the same thing, and we're going to say that's our system now. And these are the three things that can happen. Nothing else ever happens in this. We can get two solutions because you cross over. What are my solutions? There's the x-intercept. This isn't showing up that great, so I'm going to go back and circle it one more time. I can get one solution. Right? This is called a tangent point. It just touches at one point. It just brushes by it. And it's possible that we get no solutions at all. Now, this isn't like systems of linear where we have special vocabulary, so you don't have to worry about that. You just say, I can get 2, 1, or no solutions. That's all. So those are the three things that can happen. So how do we do it? Well, we can spend a bunch of time graphing. But what I did here is I dropped them in Desmos. I do want you to make sure you can put these in and you know how to type them in. I'm just going to click on them because I put them in there to get started with. Remember some things, right? Negative b over 2a. This thing's going to be a mess. Okay, major idea, it opens up. Okay, so this is my red one right here. It opens up because a was positive 1, and it has 0, negative 2. 0, negative 2 is definitely the y-intercept. Those are the things I want you to make sure you know. Other than that, graphing technologies are amazing. We're going to get all this stuff done. So, what are the solutions of the system? I want to know where they cross. Look, they cross two places. 2, 0, negative 2, 4. That's it. That's it. Alright, pretty cool. Alright, next slide. You got the other two. Again, reviewing some things that we should know. We have 0 and 1. Look at that, spot on right in the middle. And it opens up because a is positive 2, and it should be a little bit taller. That looks taller than the other one, so that's pretty good. Out of the other one, we're going to start at 5. So we start up here at 5. We're going to go down 2 and over 1. So I found 1 point already, and we didn't even put it on the graph yet. So there it is. Yeah, so there are two solutions for the second time around. All right, I'm going to leave all these on. That way it shows up in the takeaways, and we should be in good shape. Okay. But if you ever want to graph it, we're going to use Desmos graphing calculators. Make sure you know that you put it in right. Alright, other than that, we are working on solving these things algebraically. And I'll be honest with you, this one's one of the harder problems. So I'm going to skip over it and then come back to it. Don't let me forget though. because I want to start with something that looks a little bit more basic, has some easier numbers to work with, and then come back to it, because I don't want to overwhelm you, because this is new, right? If it wasn't new, then you would have skipped this already, and just went and did some work on it. Alright, so we got x squared minus 6x plus 10, it equals 4 minus x. So you're going to add x and subtract 4. Because I want to get everything on one side. Because, you know, it wouldn't be an algebra problem if everything was separated. So we want to make sure that we have everything together and it equals 0, right? Standard form. Why do we keep saying that? Because it's so important. Are there factors of 6 that add up to 5? You betcha. But you guys know one thing. 6 scares me so bad. Be careful. 6 that adds up to 5, that is not 1 and 6. 1 and 6 makes 7 when you add it up. It has to be 2 and 3. Alright, that's what scares me. And we want the signs to be the same, both negative. Alright, so we have x equals 2 and x equals 3. Now here's the problem. That is the solution. That works out just fine. But that isn't a solution to the system. So what I have to do is I have to say 2 and what number and 3 and what number make up the system. If I was a betting man, I would say that you're going to pick this bottom equation. I don't really bet, but I do know that you're going to pick that one. Because you'd like to do 4 minus 2 to get 2, and you'd like to do 4 minus 3 to get 1, and those are your answers. If you were to graph this thing, that's exactly where it would cross over. Alright, so that's what we're after. Alright, let's do one more that kind of reaches in the middle, and then we'll go back to that pool problem. I promise we're going to go back to it. I know you're thinking about the pool already. It's summertime. It's not summertime. It's like 40 degrees today. I don't know what day you're watching this, but it's not warm enough today for the pool. Alright, the only problem with this one is it's not exactly the way we want it to be yet. So I want this to be y equals, I'm going to add 30 over. So I'm going to start with that. 12x plus 30 equals x squared plus 11x minus 12. System of equations, we're using substitution. It's beautiful. Let's go ahead. We're going to subtract 12x and subtract 30 because we want it in what form? Standard. Alright, so we got x squared minus x minus 42. Alright, you can do this. It's still one of those JV problems. We're in really good shape. We're in good shape. Don't stress. Don't stress. So, factors of 42 that are 1 apart are 6 and 7. But I want negative 1, so I'm going to make negative 7, positive 6. So far we got negative 6 and we got positive 7. So here we go. Negative 6 gives us what? And positive 7 gives us what? So I'm going to go to this equation that I made right here up top. So I need 12 times negative 6 plus 30. And that answer is going to go here. I need 12 times 7 plus 30. And that answer is going to go right in here. Alright, so 12 times negative 6, we get negative 72 plus 30, negative 42. I did my math right here. If not, just let me know. And 12 times 7, we're at 84. And we're going to add 30 to that to get 114. Alright, it's a good thing we're not graphing, because this is a huge graph. Right, I got to go the whole way down to negative 42 and the whole way up to 114. It's probably off the screen. You know what I mean. Alright, so that's what we're looking at. Alright, let's go back. I promised you that we're going to go and get that pool problem done with. Now that you have an idea of what in the world's going on, so we can try it out. Same thing here, guys. The only difference is it's a real world problem, so the numbers are a little bit more intimidating. We're going to set them equal to each other. 20x plus 124 equals negative x squared plus 39x plus 64. Now this seems a little bit strange, but I really like A to be positive. So although it seems like more work, I'm going to add or subtract all these things off to the right. So I'm going to add x squared, I'm going to subtract 39x, and I'm going to subtract 64, so that this whole side turns into 0, and this side starts with a positive x squared, because we like to be positive. Stay positive, my friends. We're going to get negative 19 for the x's, and we're going to get positive 60. Alright, so everything you learned about sine rules works now because a is positive. And if you did it the other way, take out a GCF of negative 1, no big deal. Alright, factors of 60 that add up to 19. Alright, if you need some think time, pause it. I get 4, I get 15. They're both negative. So we're going to plug in 4. So on the 4th day, how many people went to the pool? On the 15th day, how many people went to the pool? And I know you guys. I love you. So I know you're going to use this linear equation. Because you put in that quadratic, you got all sorts of stuff going on. It's just not cool. Alright? I mean, as long as you get it right, it's cool. But I want you to work smarter, not harder. Alright, so plug in 4. We're at 80 plus 124. The 2's aren't showing up today. So that's 204. I know, you're thinking it's just my handwriting. But it's really not that bad today. Alright, so in the other one, we're going to plug in 15. Alright, so 15 times 20. Well, 15 times 2 is 30 plus another one, so I get 300 plus 124. So that means on the 15th day that the pool was open, they had 424, what do you call them? People at the pool? Oh, people in attendance. Alright, so day 4 and day 15, these two pools were matched up. Alright, so I promised I'd go back to it. We did. And, alright, so here's the understanding. Make sure we have this one straightened out. So, can you draw this? So, start off with the graph. Put it in Desmos. Didn't really have to do much with it. Can you draw something that has 2 solutions, 1 solution, and no solutions? Quadratic and linear. And then I leave room for your questions. Get it? Room for your questions? If not, just color it. Put it in the takeaways. That way I can take a look at it. Have a good day.